So this is my code for this week's lab. This week's lab has two parts. The first part is your task to print a sequence of numbers and use a pattern provided by the user. To do this, you want to validate user input to make sure it's between 3 and 10. So if it's less than 3 or greater than 10, it loops back and asks the user to input the correct number. You also want to get the first character of a pattern that the user enters. So if a user enters a string of, let's say, 10 characters, you want to use the first character and use it as a pattern. So in my example, if you use asterisk as the first character, you're going to use that as a pattern. For part 2, you're given an array of 4 elements, 10, 20, 30, and 40, and you want to rotate that. So what happens is that the last element of the array becomes the first element, and the whole array is shifted to the right. You also want to reverse that. So reversing 40, 10, 20, 30, we're going to get 30, 20, 10, and 40. So in assembly, what I first did was I called the readInt function to read the user entry. I then compared this to 3, and if it's less than that, it jumps back to the top of the label over here. Otherwise, I compare it to 10. And if it's greater than that, I jump back again to the label. Otherwise, I assign the variable to the number. So to read the user pattern input, what I did was I just called the readString function here. And I have my pattern set at byte 2. This allows me to just obtain the first character of a string, regardless of how long that string is. Afterwards, I initialized I to the number entered. And then for an outer loop, what I did is I compared I to 0. If I is less than or equal to 0, I jump to the outer loop completed all the way down here, which basically just calls the registers. Otherwise, I initialize j to 0. So for the inner loop, what I did was I incremented j by 1. I then moved the number to the EAX register, and then I compared j to the EAX. This is effectively comparing j to the user input. So if j is greater than, it jumps to the inner loop completed label all the way down here, which just decrements I by 1. And then it jumps back to the outer loop all the way here. So this process continues as long as I is greater than 0. Going back up down here, as I move I into the EAX, I compare j to EAX, which is comparing I and j. If I and j are not equal to each other, I call this label. This basically just outputs the pattern and jumps back to the inner loop up here, which increments j again. So going down here, if it is actually equal to, what it does is I move the variable k to the EX register, and I just call the right decimal function, which just prints the variable k. I then also incremented k by 1. And lastly, I jump back to the inner loop. So this whole process continues until j is less than or equal to I, in which case it jumps to the inner loop completed, decrements I, and it jumps to the outer loop actually. So once at the outer loop, this whole process continues until until I is less than or equal to 0. After which it just jumps to the registers. So if we run this, it's going to take a while. So if I enter a number 2, it's going to reject that. If I enter a number 20, it's also going to reject that. But if I enter a number 8, it's going to call for the pattern. And I put, let's say, period. And I'll put some garbage next to it. It's going to reject all of those except for the period and use that as a pattern. Now we're going to get that one. So for part 2, you are given an array of 4 elements. And what you want to do is you want to rotate this such that the last element of the array, in this case 40, will become the first element. And then you want to reverse that such that when you print it, it becomes 30, 20, 10, and 40. So what I did first was I printed the array in the forward direction. This is fairly straightforward. So what I did was I dereferenced ESI and placed that into the EX register. Oh, before that, what I did first was I moved the address of the array using the offset into ESI. I then moved the length of some of my array, which is 4, into the ECX register. I'll use this as a loop counter. Going back to the label, I then called the right decimal and the caret return line feed. So this just outputs a number. I then move the pointer in ESI to the next element, and I then call the loop function to jump back up here, and this one runs again until ECX becomes 0. So to rotate the array, what I did first was I initialized ESI with the last element of the array, in this case 40. I then stored whatever the value of the array at that index into EBX. And lastly, I put the length of the array minus 1, in this case it's 3, into ECX. Now to rotate the actual array, what you want to do is create another loop. So what I did is I decremented ESI and I assigned the values of the array at that index to EAX. I then assigned the previously stored value into that register into the array at the incremented index. And lastly, I moved the pointer to the left using the sub function. And I also called the loop again to jump back up here. It's going to keep doing this until ECX is 0. And after that, I moved whatever was stored in EBX, which was in line 39, into the 0th index of the array. And I just printed the rotated array using the same procedure as this one. Now to reverse the actual array, what I did was I moved the address using offset of the array to either ESI or EDI. I then moved the length of the array, which is 4, into ECX, so we can use this as a counter. I then dereference either ESI or EDI, and I assign them to either EAX or EBX. I then swap these elements. So I swapped EAX, which was originally ESI, and placed it into EDI. And similarly, I moved EBX, which was EDI, into now ESI. And I moved the pointer using add or sub. If I use add, it moves the pointer to the right of the previous pointer. If I use sub, it moves it to the left of the previous pointer. Afterwards, I decremented ECX, and I then compared ESI to EDI. If it's greater than or equal to it, it's going to jump to Z1, which is just a caret return line feed. This just prevents an exception from being thrown if they're equal to each other. And I call the loop again. So finally, I did another print here array, so it's the same thing as the first one. I moved the address of the array using offset into ESI. I moved the length of the array, which is 4, into ECX. I have another loop body here, so I dereference ESI, moved it to EAX, called the right decimal and the caret return line feed function, which prints the output. I then move the pointer in ESI to the next element. And lastly, I call the loop function, which just repeats this until ECX is 0. So if we run that, so as you can see, it's printed 10, 20, 30, 40. This is the forward direction. I then rotate it. So the last element is now the first. So it becomes 40, 10, 20, and 30. And I then reverse it. So it becomes 30, 20, 10, and lastly 40.